So now that we've reviewed a little bit of what we learned last year about how to evaluate limits, it's important that we talk about something called indeterminate forms. And this is a really neat topic. Right now I'm going to give an informal definition, and then I'll try and sort of show you what indeterminate forms are through some examples. So my informal definition is that an indeterminate form is basically a form of an expression that we don't know the value of without carefully considering what the limits are of the functions that are involved. One example I can give you of an indeterminate form right now is 0 over 0. Right? And the reason that that's an indeterminate form, like using my informal definition above, is that if you have a limit that's approaching 0 over 0, we do not know what it is. It could be anything. We need to have a more careful consideration of the limits involved in order to figure out what this limit really is. So there are actually 7 different indeterminate forms that we're going to talk about. 0 over 0 is just one of them. Before I really show you what the indeterminate forms are, I'd like to show you what some determinate forms are. In other words, expressions that we totally know what they are. There's no debate, there's no question about what they are. So in this segment of the video, I'd sort of like to make a list of determinate forms, and then what I'd actually like to have you guys do is actually you figure out what their values are. So I've got, I guess 9 of them here. And for these 9, I'll put it up on the screen, and then you can pause the video and sort of think about what the value of that thing is going to be, and then check it. And the idea is you should notice that with each of these, you know what it's going to be, right? So suppose that we have a limit that's approaching n over m. In other words, you've got a limit that's approaching like 5 over 2 or 7 over 13. Like if I asked, oh, what is the value of n over m? N over m is n over m. As long as m is not equal to 0, that's just a fraction, right? And we know exactly what that thing is, right? The next one for us to think about is this one. What if you had a limit that was approaching n over infinity? Pause the video and think about that. We all should know, there's no debate as to what some number divided by infinity is. Hopefully you pause the video, or at least you said it out loud. It's 0, right? Similarly, what about n over 0? Right? If you have some number and it's being divided not by 0, but by something getting closer and closer and closer to 0, is there any ambiguity as to what that's going to be? The answer should be no. This is going to be infinity. Now, it could be plus or minus infinity. We're not sure which one. It depends which side we're approaching from, but it's not like it could be anything. Something divided by 0 will either be positive infinity or negative infinity. This is another silly one. What about 0 divided by n? If you have a limit that's approaching 0 divided by some non-zero number, there's no debate. This is turning into 0. Right? The purpose of these things, by the way, is for me to show you how obvious determinate forms are. When you have a determinate form, it's not hard to figure out what it is. I've got 5 more, and I'll list them out a little bit more quickly. What if you have 0 times n? What's that approaching? That's always going to be approaching 0. Right? What if you have some number times infinity? Okay, what's that approaching? Should be approaching infinity. Again, it might be plus or minus, because the n could be negative, right? Well, that's fine. What about 0 raised to some power? 0 raised to any power is 0, right? What about some number raised to the 0 power? Again, no ambiguity here. We know anything to the 0 power is 1, right? And finally, what about 0 to the infinity power? If you have a super duper small number like 0, and you're raising it to an infinite power, this is going to turn into 0. These are all determinate forms, right? These are all things that if they show up in a limit, you're excited because you're like, oh cool, I can totally do this. If you have a limit that's approaching 0 to an infinite power, you know that's going to be 0. So these are the determinate forms. They're the nice, easy ones. In the next segment of the video, I'm going to cover the 7 indeterminate forms, and I'm going to try and give you some justification as to why they're indeterminate. So again, I mentioned there are 7 indeterminate forms. 2 of them you're already aware of, right? The 2 that you are already aware of are 0 over 0 and infinity over infinity. Right? Back in the first year calculus class, you learned how to deal with both of these. For 0 over 0, it was sort of like try harder. We'd either use factoring or we'd use some other method. We had some methods for that. Infinity over infinity, we usually use the method of dividing top and bottom by the highest power of x in the denominator, and we sort of just worked through that, right? But what's key about these is that these are indeterminate forms. Like on this section of the video, I'm not going to say, oh yeah, 0 over 0, that's approaching blah. Because it's not always approaching the same thing. All 7 of these are indeterminate, and we need some other method, a method that I'm not going to teach you in this video. That'll wait till tomorrow, actually. We're going to need some other method to figure out what they are. right? And some of them are going to bother you, right? Let me start with the easiest one to deal with. The easiest one to deal with is infinity minus infinity. If you have a limit that is approaching infinity over infinity, you do not know what it is. Now, somebody might say, whoa, 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 shouldn't that be zero? Like, I mean, isn't it just zero? No. And the reason is one of those infinities might be bigger than the other one. And at this point, you start going like, oh my god, there are different sizes of infinity? Absolutely. An example I could give you of this one. What if I asked you, what is the limit as x approaches infinity of x squared minus x? Right? As x approaches infinity, this is going towards infinity. This is also going towards infinity. So this is infinity minus infinity. But would you agree that this is getting closer to zero? I hope not. Like, imagine plugging in like 50 million here. 50 million squared, okay, astronomically large, minus 50 million. Dude, like, nobody even cares about this 50 million over here because this is so huge, right? When you have infinity minus infinity, it could be any number of different things. And so we can't just jump to saying, oh, it's zero. It's an indeterminate form. We need to do more work to figure out what this thing is, okay? So that's 3 down, 1, 2, 3. We've got 4 left to go. I'll move now to the next most palatable one, and that one is 0 times infinity. This one's going to bother people a lot, because you guys have all been trained that 0 times anything is 0. And it's true. If it's actually 0, then yes. But this 0 isn't actually 0. This infinity isn't actually infinity. What I'm talking about here is I'm talking about a limit where one of the things is getting very, very, very small, and one of them is getting very, very, very large. I mean, again, let me sort of give you a side example of this. Suppose I asked you, what's the limit as x approaches, let's just x approaches 0, of x times the natural log of x? Right? I mean, and I don't know if you guys remember this about natural log x, but when natural log x has an asymptote at 0. Like, this is approaching negative infinity. In fact, I have to put a little plus here. So the question is, I'm not actually plugging in 0. I'm plugging in like 0.000001 for both of these things. And as I plug in numbers that are getting closer and closer and closer to 0, this is getting closer to 0, but this is getting closer to infinity. When I multiply together 0 and infinity, I don't know what I'm going to get. Now remember, I know this is confusing, it's not actually 0, it's not actually infinity. I'm saying imagine taking a teeny tiny number and a huge number and multiplying them together. Can you guarantee me what you're going to get? I mean, another way of thinking of it, imagine you and a friend are in a room and you decide, let's have fun with a calculator, and one of you types in a super tiny number and one of you types in a super large number, and you multiply them. Do you know what you're going to get? We don't. Whereas if you took that list of determinate forms from the previous section of the video, you would know exactly what you're going to get out of it. Okay? I've got 3 of these things left, and I'm going to sort of bunch all of them together here. And that may be bothersome, but oh well, we'll deal with it. The 3 last indeterminate forms are 1 to the infinity, 0 to the 0, and infinity to the 0. I'm telling you now that all 3 of these things are indeterminate forms. In other words, we do not know what they are. So if you're working through a limit problem and you say, oh, it's 1 to the infinity, 1 to any power is 1, I agree with you that 1 to any power is infinity, but in a limit, this isn't actually 1, right? In this case, I mean, somebody might say, well, anything to the 0 power is 1. Well, that's true, but 0 raised to any power is supposed to be 0. We're in this position where I don't know whether it's 0, or whether it's 1, or whether it's something else, right? This infinity to the 0, anything to the 0 is supposed to be 1, but infinity to any power kind of feels like it should be infinity. Or maybe it's something somewhere in between. Heck, maybe it could be E, Euler's number. Anything can happen. I suspect that there are going to be questions about this. So what I almost want to ask you to do now is like pause the video and write down, like, what do you want to know about this? What do you not understand about this? Tomorrow's assignment during class is probably going to be fairly short. And so I'll be ready to answer questions. So like pause the video, write down what your questions are. I do have a few sort of sample problems coming up, and I'd like you to look at those just to kind of get a feel for this stuff. But these are the 7 indeterminate forms we need to know that they're indeterminate. So all three of my examples look like this. Determine if the following limit approaches an indeterminate form. If it does, state which indeterminate form. If it doesn't, well, then actually find the limit. So how do we do this? How do we determine if this is an indeterminate form? The way we do it is we do it the way we do all limits. We attempt to plug in this value and see what happens. So what happens when I plug in infinity right here? What happens to this inside stuff, to this 1 minus 3 over x? We notice that this is approaching 1 raised to the x power, so raised to the infinite power. This thing right here is an indeterminate form. Right, so my answer here, this is an indeterminate form. And I imagine it's frustrating, but, so what this means is, great, we don't know what this thing is. We'll have to figure it out tomorrow when I teach you how to actually do these. If you really want to know, plug it into your calculator. Take this expression and plug in, 8 nines, like 9999999 for both of these. And see what you get. See if you're approaching something. We should be approaching something, but we don't know what it is. Here's another example of the same thing. So take a minute, think for yourselves. Decide whether you feel like this is an indeterminate form. Well, as x approaches 0 from the right, what's happening to cosine x? Cosine is getting closer and closer to 1. So this is approaching 1 raised to the sine x power. So the sine of 0 is 0. So this is approaching 1 to the 0. Is that indeterminate, or is it one that we actually know? In this case, it's one of the ones we actually know. This limit is approaching 1. One way of thinking of that is that there's no ambiguity here. 1 to some power is something. Anything to the 0 power is supposed to be 1. Those things kind of mesh with one another. This is acceptable. This is nothing weird going on. And then we have this last one, and this is sort of a strange one. The limit as x approaches 0 from the right of the xth root of cosine x. And you're probably even wondering, what does the 0th root even mean? To be honest, I'm not certain that I know what it means. But let's see if we can rearrange this somehow. Right? How could you rewrite this expression? How could you rewrite that root? I'm thinking we can rewrite this as still the limit. The limit as x approaches 0 from the right of cosine x raised to the 1 over x power. And if we think about it that way, we can now sort of see that this is just a power expression. So as x approaches 0 from the right, what happens to cosine x again? This thing is approaching 1, and then the 1 over x, right? As x approaches 0, this thing is approaching infinity. Is 1 over infinity one of our indeterminate forms? It absolutely is. This is an indeterminate form, which means we don't have any way of evaluating it right now, and so all we can say is that it is an indeterminate form. And I know I mentioned this earlier, I'm sure it's frustrating for you to get to the end of these problems and have to be at the end of this video and go, oh cool, so we just learned a whole lot of stuff that we don't know how to do. Exactly. I need us to focus our attention today on what we do and don't know. What are determinate forms? In other words, what can we figure out? And what are indeterminate forms? What do we need help with? And tomorrow's lessons will all be about the help that you need to do the problems that you don't know how to do. Okay? So I'll see you in class. By the way, I'm totally serious about writing down your questions about what doesn't make sense about indeterminate forms. This is a really strange topic and one that deserves discussion and us talking about it. So write them down and be ready with them. See you soon.